All right, so we're recording, so I'm going to go to my screen now. All right, y'all, so 1.1, we're going to be solving equations. So the first thing you want to learn when you're solving equations is how to check your answers. So to check answers, we simply replace the variable with our solutions. Now, when we replace the variable with our solutions, we're going to work it until we see if we get a true statement, okay? In a true statement, I mean, you'll get something like 5 equals 5, negative 10 equals negative 10, something like that, okay? So we replace the variable with our solutions and check to see if we get a true statement. Now, if I got something like 7 equals negative 3, that is definitely false. So that means the solution I found would be wrong, okay? So let's play with one of these. We're going to determine if the number is a solution. Okay, so they want to know, so they'll put a negative 9 with a semicolon. That means negative 9 is the number they want me to check. And my equation is going to be 6y minus 5 equals negative 58. All right, so to check this, we're going to replace the y with the negative 9. So I'm just going to put this negative 9 in for my y. So I'll have 6 times the negative 9 minus 5 equals negative 58. And if you notice, all the work I got to do is on this left side. Really can't do nothing to the right side. So let's see. Remember, when you multiply unlike signs, you're going to get a negative answer. So that 6 times negative 9 will be negative 54 minus 5 equals negative 58. All right, y'all. So when you see something like this, a negative 54 minus 5, this is like we're adding two negative numbers together. When you add two negative numbers together, it will be a negative answer. So a lot of people get this mixed up with multiplying and dividing, where like signs are always positive. But remember, when you add like signs, they're going to stay that sign. So then we just figure out what 54 and 5 give me 59. So negative 54 minus 5 gives me a negative 59 equal to this negative 58. So we can tell by this is definitely a false statement. So this is the false statement. So what that tells me is that negative 9 is not a solution. Okay. So to be a solution, this would have said negative 58 equals negative 58, or negative 59 equals negative 59, okay? So that's what we do to check our answers. So is that making sense? All righty, so we're going to start solving equations. So to solve equations, I got to give you a few rules. So we're going to start out playing with what we call the addition principle. of equations. So, y'all, this addition principle of equation tells me if I got two things equal to each other, such as A equals B, if I got two sides equal together, then I can add the same thing to both sides. So I can add C to both sides and they would still be equal. So basically, this addition principle is telling me if I add something to one side of this equal sign, I definitely got to add it to the other side of that equal sign, okay? Now, also this works for subtraction. It follows under the addition rule. So if the two sides are equal, then I can subtract the same number from both sides and they will still be equal. So this addition principle is basically how I'm going to move something from one side of that equation to the other side of that equation. Because my whole goal, remember, is to get an x or whatever my variable is on one side equal to some number. So we'll start out using our addition principle. Okay. So we're going to solve this equation. We're going to solve x plus 4 equals 24. So y'all, here's my goal. I want to get this x by itself on the left side, but I got this 4 I need to move. Now, the only way I can move that 4 is to get it to zero out on that left side. So if I want to zero this 4 out on the left side to get my x by itself, I'm going to come in and subtract 4 from both sides. So we're going to subtract 4 from each side. All right, because remember, when I do to the left side of equals, I got to do to the right side of the equals. But y'all, look what happens. My x comes down. This 4 and negative 4, they cancel each other out on my left side. So all that's going to be left over here is our x. So now we just got to figure out the right side. We got like terms over here, the 24 and the negative 4. So basically 24 minus 4 would give me a 20. So if you wanted to check that, you're going to put that 20 in for that x and see if this is a true statement. So to check this, I would have 20 plus 4 equals 24. Well, that's nice because 20 plus 4 does equal 24. So I get 24 equals 24, which does check for us. So this little addition principle is not bad, but it gives us a way that we can move something from one side and get it to the other, okay? So I got a question on that? All righty, I'm not seeing anything, so I'm going to pull my paper down so I can get my next problem. Oh, yeah, what about this? A negative 20 plus an x is going to equal a negative 90. All right, y'all, let me pull the chat up real quick. All right, good job. All right, y'all, so once again, I want to get this x by itself on the left side. So we need to take care of that negative 20. So you'll notice when numbers are positive, I subtract. When they're negative, let's see what my chat's saying. We're going to cancel the 20 out. Good job. And to cancel that 20 out, we're going to add a positive 20 to both sides. So on this one, I'm going to add 20 to each side. So you notice if the number is positive, its opposite is negative. If the number is negative, its opposite is positive. But y'all look at that. The 20s cancel. All that's left over here is our x. Woo, so now we just got to figure out what a negative 90 and a positive 20 equals. When you're adding unlike signs, you're going to subtract the numbers and give the sign of the larger number. And y'all look at that. My chat's saying negative 70, which is correct. Because 90 minus 20 is 70. The larger number is negative, so my answer stays negative. And y'all, if you put that negative 70 in here, negative 20 plus negative 70 does equal our negative 90. All right, y'all, so let me see what that chat's saying. All right, so I'm going to flip the page now. And then move this back up. All right, y'all, how about a y minus 1.65 equals 79.4. Now, I'll say this, calculators are not required for this class. But we don't mind you using the calculator. So on this one, I would probably punch it on a calculator. Now, if you're doing it by hand, what do I need to do to my 1.65? Now, let me let one in real quick. All right, so we need to move to negative 165. I see the chat's hitting up again. So we're going to add it to both sides. Good job. So we're going to add 1.65 to both sides. And someone's got an 81.05. So yeah, because remember, if you're adding those, you would want to add a 0 for a placeholder here. And then just add straight up and down. There's your 5. 4 and 6 give me 10. So I'm going to carry the 1 and put my decimal. 9 and 1 is 10, and 1 is 11. Carry the other 1, and there we go. We get y equals 81.05. And that's what y'all are getting online. Good job. All right, y'all, any questions on that one? All right, so how about I do one with y'all's favorite number? Y'all love fractions. So let's try this. Negative 5/8 plus the x equals a negative 11 over 24. So fractions might not be fun, but we got to deal with them, okay? So I still need to get the x by itself. So to get that x by itself, I'm going to add the 5/8 to both sides. So I'm going to come in here and add me a 5/8. So y'all think about this. Since I'm dealing with fractions, I cannot add these fractions together unless these denominators match. So I got a 24 on the bottom of this one and an 8. So let's play with that. Got negative 11 24ths plus 5/8. In order for me to add these fractions, we need a common denominator on the bottom. So the common denominator is the smallest number that the 8 will go into and the 24 will go into. So think about this as multiples. If I had a 24 and I doubled 24, I'd get 48. If I did 24 times 3, I would get 72. So I'm looking for multiples of 24, which will be 24, 48, 72. Then I would do the 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. And so on. Now, I've got a common number at this point. So y'all, what would I go with my LCD? What's the smallest number that I got in common in both those lists?
24.
24. So that means 24 is going to be our common denominator. So the top fraction already has a 24 on the bottom. So we're good with it. The bottom fraction, I got to change these to have a 24 on the bottom. So what would I multiply the 8 by to get me a 24?
3.
Okay, so since I multiplied the bottom of the fraction by 3, guess what? We got to multiply the top of that fraction by 3. So this gives me what? 5 times 3 would be 15 over 24. Now, we're going to add these together. And remember, at this point, the bottom will be a 24. All the adding and subtracting is going to get done with these top numbers. So we got a negative 11 adding to a positive 15. What are y'all getting out of that? All right, good job. Looks like Chantel and Monica got me a 4. Good job. Now's the point where we would reduce the 4 and 24. So I'm going to reduce this. Y'all, here's the question. When you reduce a fraction, you're going to divide out any factors they have in common. So the largest factor these two have in common would be a 4. So we're going to have to divide the top and the bottom by 4. So on top, you got 4 divided by 4, which will give you a 1. On the bottom, you got 24 divided by 4. Let's see, Chantel, you got it, which will make me a 6. So this 4 over 24 reduces to a 1 over 6. So this cancels, and I get my x equals a 1 over 6. See, all the fractions are tricky because we got to find the common denominators and all that. Now I'm going to pull up my calculator. Now, if you don't have a TI-83 or a TI-84, you can get the phone apps of them. They have phone apps you can get from the Apple Store or from Google that have the graphing calculators on those also, okay? So let me pull up my calculator for us. All right, I just want to clear this main screen. So on the calculator, watch, you can add fractions. So I had a negative 11 24ths. I would do negative 11 divided by 24. And we have to add that to a 15 divided by 24. So there's my two fractions. I'm going to hit enter. And I got a 0.16666. Well, MATLAB don't want that decimal answer. We're going to turn that back into a fraction by hitting the math button on the left side under the green one. There's a math button. You hit it. Number 1 says fraction. That means it's going to turn my answer into a fraction. So I hit enter on that. And there you go. We would hit enter one more time and we get a 1/6. I'm gonna show you another way you can do that. By putting it in the calculator to look like a fraction, it'll give me a fraction answer. So to put them in as a fraction, y'all, if you'll hit this green alpha button and then the y equals button and hit enter for number 1, n over d means numerator over denominator. All right, y'all, let me let one in real quick. All righty. So now that I got it looking like a fraction, I can put in my, what am I adding? Negative 11/24. So I can put my negative 11, arrow down, put in my 24. And then I'm going to arrow right, put in my plus. My second fraction, I would hit alpha y equals again, and then enter. And my second fraction was 5/8, so I would put my 5 on top, arrow down, and put my 8. Oh, we could have did this on my top one. I think I went with once we already found the common denominator. But if I'd have put a 5/8 there, I'd have got the same answer. So y'all, here we go. Negative 11/24 plus 5/8. We know that's going to give us, when we hit enter, a 1/6. So if you don't like fractions a lot, get you a calculator to sort of help you out, okay? All right, y'all, next principle coming up. And this is what we call the multiplication principle of equations. So this one says, if two sides are equal, so if A equals B, then I can multiply both sides by the same number and they're still equal. Also, what follows under this multiplication rule would be division. If I had two sides equal, I could divide both sides by the same thing and they'll still be equal. No, there's only one thing on this one. You cannot divide by one number. So what can C not equal? Oh, how about a 0? Remember, we're not allowed to divide by 0. That makes this what we call undefined, okay? All right, y'all, so I'm gonna move this down so we can work some of these examples. So we're gonna solve by using our multiplication principle. So y'all, how about this one? 4x equals 24. So here's my goal. I don't want this to be 4x's. I want that to be 1x there. So what can I do to the 4 to turn it into a 1? Well, y'all, I'm going to come in and divide both sides by that 4. So I'm going to divide both sides by 4. So y'all, look at this. Those 4 divided by 4 gives me a 1x. Now remember, if I do not put a number in front of that x, it's understood to be a 1. All right, then we got what? 24 divided by 4 gives me 6. So let me check that. 4 times 6 equals 24. That is a true statement. So we know we did that right. So y'all, here's the thing. Well, go if they added, I subtracted. If my numbers were negative, I added. Well, guess what? If they're going to multiply, I'm going to divide. And if we got any where they're dividing, I'm basically going to multiply, okay? All right, let's turn the page now. So y'all, how about if I did a negative 14y equals 28? Once again, they're multiplying that negative 14 times the y. So on this one, we're going to divide both sides. So we're going to come down and divide both sides by the negative 14. You got to divide by the same sign, okay? So that's going to give me 28 divided by that negative 14. Notice, when I added or subtracted, we did the opposite signs. But when you're dividing or multiplying, you want to use the same sign, okay? Because remember, a negative divided by a negative makes that a positive 1y. And how about this? What are you going to get on this? 28 divided by a negative 14. Oh, good job. That was quick. Negative 2. So remember, like signs are positive. Unlike signs are going to be negative. All right, put that negative 2 in. Negative 14 times negative 2 does give me a positive 28. So y'all, equations ain't that bad. It's just basically you're undoing all their stuff that they did to make the equation. All right, let's see what we would do here. Negative x divided by 2 equals 10. So here we go. This is a negative x divided by 2 equals 10. So we're going to take care of this negative and the 2. So since they're basically dividing, I'm going to multiply both sides by a negative 2. And Chantel, you're good. Negative 2 on that, right? So multiply that negative 2. And this was what? A negative x over 2. That's going to equal 10 times my negative 2. Because y'all, what's going to happen? These negative 2's are going to cancel. All that's left is my x. And then what would y'all get on this? A 10 times a negative 2. So negative 20, good job.
Negative 20.
Yeah. So just remember, those unlike signs are going to be negative. Like signs are going to be positive. And y'all, that's a trick. We want the x's being positive. That's why I use the negative 2 up here. Because remember, negative times negative made it positive, okay? All right, let's see what I got here. 4.2x equals a negative 37.8. So they're going to hit you with a decimal probably, and then a fraction, right? So on this one, I got 4.2x. I'm going to divide both sides by the 4.2 to make that a 1x. Oh, y'all, so that 4.2 divided by 4.2 gives me my 1x like I needed. Ooh, okay, let's see. I'm going to have to probably pop that on my calculator real quick. So let me hit my calculator and see what that gives me. So we got a negative 37.8 divided by 4.2. All right, y'all, we hit enter. Oh, y'all got it on there. -9. Good job. Okay. And that's the trick on these, is just coming through, trying to get that variable on one side, everything else on the other side. All right, y'all. So the next ones, I'm going to give us some steps we're going to follow. Because now they're going to start combining both these principles using the multiplication and the addition. So let me give you some steps. And let's see, we'll hit some of these. Oh no, hang on, I had one more to do. So let me pull it over here with my fraction. I wanted to do this fraction one for sure. Show you what I would do to this. I got a 3/2 t equals a negative 1/4. So I wanted to show you what I would do with one of these that had a full fraction here. So since I got a 3/2 t equals to negative 1/4, I would basically divide by 3/2. But remember, when you divide fractions, we don't really divide the fractions. We're going to flip it and multiply. So what you would do in this case is multiply both sides by 2/3. So then I would take the other side and multiply by 2/3. Because y'all look what happens. So remember, when you got a fraction that's got a top and a bottom, flip it and multiply. Because you see these 2's are going to cancel. These 3's are going to cancel. Anytime you got numbers on top that matches these bottoms, they cancel. So all that's left is the t. And y'all right here, I'm going to multiply straight across and then simplify if I needed to. Now, we'll tell you a trick. You can simplify before you multiply. You see the 2 and the 4? Those would reduce by dividing 2 out of both of those. So you could make this a 1 and then this 4 a 2. But I'm just going to multiply it and then we'll worry about reducing. So remember, fractions multiply straight across. So negative 1 times 2 gives me a negative 2. 4 times 3 gives me a 12. Although negative 2 over 12 is correct, it's not simplified all the way. So you would have to figure out what's the largest factor they both have in common and then divide that out. And y'all, looks like both of these are going to divide by a 2. So on top, negative 2 divided by 2 gives me negative 1. And then on bottom, 12 divided by 2 gives me a 6. Now y'all watch this. See how I had to reduce at the end? I could have took this negative 1/4 times 2/3. I could have reduced it right here. 2 goes into 2 1, 2 goes into 4 twice. And look what you get. Negative 1 times 1 would give you the negative 1 on top. 2 times 3 would give you the 6 on the bottom. Some people like to reduce before they multiply because they get smaller answers. But like I said, it don't matter when you reduce as long as you reduce that answer. All right, so that's my fraction one. So now I'm going to give you my steps. So the first step I do, I'm going to combine like terms on either side if needed. So if I got x's on one side, I'm going to add them together. If I got numbers on one side, I'm going to add them together. And that's only if needed, okay? So once I've combined my like terms, I'm then going to try to move my variables on one side. So get the variables on one side of the equation. So if I got x's on both sides of equals, I'm going to do my adding and subtracting to get them all on one side. Once I've got my variables on one side of the equation, I'm going to get the numbers on the other side of the equation. Okay, so I'm going to try to get my variables on one side or the other. I can get them on the left side or the right side. It don't matter. But once I get the variables on one side, all the numbers will go to the other side. At that point, I should have so many x's equals some number, which means my next step will be doing this division or multiplication. So I'm going to divide or multiply to get a 1 in front of the variable. And remember, if I divide on one side of that equation, I'm going to divide the other side by the same thing or multiply, okay? And y'all, after we do that step, only thing left, if we want to, check if needed. So y'all, before I get into these, let me ask y'all a question. I'm going to refresh. What is this equal? 2x plus 3x. So what does that equal?
5x.
Okay, good job. That definitely equals 5x. So notice, y'all, when you add like terms, you do not change what those variables look like. If you're adding x's to x's, you're just going to have more x's, okay? We do not change exponents when we're adding variables, okay? All right, y'all, so we're going to try to combine like terms on each side if we need to. We'll start moving our variables, then we're going to move the numbers. Then if we need to, we'll divide or multiply to get a 1x or a 1y. And then if you need to, we're going to check. All righty, so let me flip over and let's do some equations. All right, y'all, so let's see. How about a 6x minus 9 equals 21? So they'll start out where I don't have to do the like terms right off the bat, but eventually they're going to get into that, okay? But this is 2 steps. So my first step, I want to get the 6x by itself. So since the x's are on the left side, that means all these numbers are going to the other side. So y'all, since that's a -9, what are you doing?
And
So yes, we're going to add 9. So there you go. Add 9 to both sides. So if I bring that down, so here we just add 9 to both sides. Oh, y'all, so the 9s are going to cancel on the left side, leaving me my 6x. And let's see, 21 and 9, that's going to give me 30. All right, y'all, I got a 6x equals 30. What are y'all going to do to turn that 6x into a 1x?
divide.
There you go. So now we're going to divide both sides by the 6. So here we're going to divide both sides by 6. All right, now that should finish this out, right? The 6's cancel, making that a 1x. And then what we got? Oh, good job. Y'all done got it. Y'all got a 5 up there. 30 divided by 6 is definitely a 5. So if you check this, 6 times 5 is 30. 30 minus 9 does equal 21. So y'all, they're not too bad. It's just sort of, you just undo what they did, okay? It's almost like we're doing order of operations in reverse. All right, so let me try one and then I'm going to show you what I would do to these ones. I would do these ones a little different on my fractions when I hit it. All right, y'all, 8x plus a 4 equals a negative 60. First step we're doing to that. We're going to move that 4. And there you go. I'm going to subtract 4. So we're going to come in, subtract our 4 from both sides. So my 8x, the 4's canceled out on that side. Now remember, here's where I get a lot of mistakes. When people add a negative 60 and a negative 4, they put 64. But remember, when you add 2 negatives, that answer will be negative. And then you add 60 plus 4 and you get what? A 64. So remember, adding 2 negatives, you add the numbers and keep them negative. All right, so now I got an 8x equals negative 64. We're going to come in now and divide by the 8 because we need to make that a 1x. So y'all, that canceled again, giving me my 1x. Unlike signs, well, y'all have already got it. Looks like what, a negative 8. Good job. All right, y'all. Let me show you what I would do to this one. I got a negative 7/3 x plus a positive 2/3 equals negative 11. So when I got the variable as a fraction and the number as a fraction, I like to get rid of these fractions. Now I'm going to show you a trick how to get rid of this fraction. I'm going to get rid of the fraction by multiplying every term. That means this one, and this one. I'm going to multiply every term by, well, what we get rid of the 3's on bottom is if I multiplied everybody by a 3. So that's how I get rid of fractions. So watch, let me multiply all these by 3. 3 times my negative 7/3 x plus 3 times our 2/3 will equal 3 times our negative 11. Now watch this. These 3's cancel. All that's left is a negative 7x. That's going to be plus. These 3's cancel, leaving me a 2. So the fractions, all that 3 did was cancel them fractions out. Now over here, we actually do got to multiply these. So remember, I've got a 3 times a negative 11. That's going to give me what, a negative 33. Now, y'all, the fractions are gone. All we got to do is solve this and be done. So what would y'all do as your next step?
Subtract 2 from both sides.
Yeah, I'm going to definitely subtract 2. So you're going to get your negative 7x. 2 negatives are going to stay what? Negative 35. All right, y'all got one more step and we'll be done with this.
Divide negative 7.
All right, I'm going to divide negative 7. So guess what? There you go. That cancels, giving me 1x. All right, negative divided by negative. Good job, Zion. That looks like a positive 5. So they're not too bad, are they? You just got to sort of play with these. Let's see what y'all would do to this. -1 plus 20x equals 20x minus 1. So I don't have like terms on each side, but my variables are on both sides. And I'm going to try to get all my variables on one side. So to move this 20x to this side, I would come in and subtract my 20x. Y'all look at that. This negative 20x and 20x canceled. This 20x and negative 20x canceled. All that's left over here is a -1. All that's left on the right side is a negative what? Anytime you work an equation and you get something like -1 equals -1, 5 equals 5, or something like that, when you get a true statement, this means that this solution is all real numbers. What that means is it don't matter what I put in for this x, I can put any number I want to in for that x on both sides, and this will always be true. So it's going to be true for what we call all real numbers. Now I'm going to show you another one like that. So y'all got that? I'm going to change my page. What if that was like this one I'm about to do? What if I had a 10y minus 15 equals 19 plus 10y. So remember, I'm going to try to get the y's on one side again together. So to move this 10y to this side, I'm going to subtract 10y from both sides. Well, y'all, if you notice again, these 10y's cancel. These 10y's cancel, which means I get a -15 on the left side equal to a positive 19 on that side. Well, guess what? This is a false statement. So when we get a false statement, we say that there is no solution. Okay? True statements mean it works for any number. If it's false, that means there's no number that I can put in for them y's to make these equal. So we call that a no solution. So y'all, let me ask y'all something. Have y'all ever heard of a little property called the distributive property? So the distributive property is when you have something like A times parentheses B plus C. So when you got parentheses with a number in front of them, we want to get rid of the parentheses. And the way you get rid of the parentheses is you take the A and multiply by the B. So you're going to get an AB plus you take that A and multiply by the C so that you get an AC. So basically, any number that's in front of parentheses gets multiplied by everything inside the parentheses, okay? So we need to know that for our next problem. They're giving me a 4 times parentheses, x plus 5, close parentheses, that's going to equal 8x. So let me say this. The first thing you got to do is get rid of the parentheses. So we're going to distribute the 4 to get rid of the parentheses. Okay, so we're going to distribute it 4. So we got 4 times x. Well, 4 times x is a 4x. Oh, look at that. Madison, you're pretty quick. That 4 times 5 will give me a positive 20. And y'all, that's going to equal the 8x. So here's a question for me. If I want to get the x's on one side, I got an x and a number here, and I just got x's on that side. So if I want the x's on one side, I'm going to move the 4x to the side of the 8x. Okay? Because then I'll have the number left here, and my x is on the right side. So when I got a number and a variable equal to a variable, I move the variable that's with the number. So I would come in and subtract that 4x from both sides. So y'all watch this. This cancels. We got our 20. That's going to equal 8x's minus 4x's will give me 4x. So y'all, it's not bad to have the variable on the right side. The sides it's on don't matter, okay? But now focus on the variable. What's my next step?
To get x by itself.
And so since I got a 4x there, we're going to divide both sides by that 4. So the 4 and the 4 cancel, giving me my 1x. And then let's see, the other side, Zion got me, what, a 5? Good job. Okay, so to check that, you just put a 5 in here. 5 plus 5 would be 10. 10 times 4 would be 40 on that side. Over here, you put the 5 in. 5 times 8 is 40. So you get 40 equals 40. So that makes that true, okay? All right, y'all. So let me try one more. And then I'm going to show you a few problems out of 1.2. So this one's got a 7 times 3x plus 6. That's going to equal 11 minus x plus 2. So guess what? They threw parentheses on both sides. So over here, you're going to distribute my 7. 7 times 3x is going to give you a 21x. 7 times 6 is going to give us a positive 42. Now over here, this 11, it's not in front of the parentheses. So this 11, we're going to bring down. All that's in front of these parentheses is the negative. So y'all guess what? When there's not a number following the negative in front of the parentheses, you got to treat this like a -1 sitting there, okay? Which means when you distribute on the second parentheses, you're going to distribute a -1. Now, if this would have been positive x plus 2, then all I'd have done was distribute a +1. But since that's minus, remember, you got to distribute that subtraction to both of these. So a -1 times x will make that a -x. That -1 times that 2 will make that a -2. So what that negative does when it's in front of parentheses, all it does was change the 2 signs. These were both positive inside the parentheses. Well, now they're both negative. Because remember, you're subtracting this whole thing, so that now we're subtracting the x and we're subtracting our 2. So y'all, the first thing you're doing to that, you're going to be adding like terms on the right side, because you got 11 and a -2 over here. So the first thing we're going to do over here is combine the like terms. So the left side is going to stay the same. 21x plus 42. All right, y'all, if you take 11 and add a -2 to it, 11 minus 2 gives you a 9. And then you still got your -x. All right, so remember, when you add like terms, all you're doing is taking these two numbers and adding them together. So you had 11 and a -2, which gave me the 9. Now, I got a 21x plus 42, a 9 minus x. What I'm going to do is get all my x's on the left side over here. So since this x is negative, we're going to add an x to both sides. So here I'm going to add x to both sides. And y'all look at that. What's that going to give you? 21 x's and an x.
$21x squared.
Nope, remember, you can't change them variables. So just treat this like a 1. Add the numbers and keep that variable the same. Oh, so now y'all got it. 22 x's plus my 42. Over here, the x is canceled, and I got a 9. But y'all remember, do not change variables when you add or subtract. The only time you can change variables is by multiplying or dividing. All right, now we need to get the 42 to the other side so that my variables are by itself. So to move to 42, I'm going to subtract 42 from both sides. I'm going to subtract 42 from both sides. So the 22x comes down. 42's cancel on the left side. So on the right side, we got a -42 adding to a +9. So the negative is the bigger number. So that answer will be negative. And then let's see, unlike signs, so we subtract 42 minus 9 gives me what, a 33. All right, y'all. My final step is to divide both sides by that 22. So I got my 22x divided by 22. That's going to equal -33 divided by 22. So divide both sides by 22. Here you go. The 22's canceled, giving me my x. Oh, and guess what, Zion? They don't want decimal answers. They want this to look like a fraction. And we don't have to write it as a mixed number. So I'm going to make it as a fraction. So 33 and 22 both divide by 11. -33 divided by 11 gives you a -30. 22 divided by 11 gives you a 2. So remember, in Math Lab, they want this to be a -3/2 instead of a -1.5. But y'all, let me show you a trick. If you got the calculator, let me go to my calculator here. If I take that -1.5 answer you took, -1.5, and I go to the math button and tell it to turn that into a fraction, remember, it will give me my -3/2. So if you do put in the decimal, it'll take decimal answers when you start with decimals, but usually when you have fractions like that, they want it to be as a fraction. All right, y'all, that was 1.1. So now let me do a little bit of 1.2. In 1.2 is doing the same thing. It's just they're using what they call formulas. So 1.2 is solving formulas. All the rules apply. So watch what I'm talking about. So this one wants me to solve for the h. Now the equation they're giving me is f equals h times q. So y'all, here's my question. I got an h times q over here. I want to get that h all by itself. So what do I need to do? Oh, I got y'all gun shy. But remember, if this was a 2h, you would divide by 2. So since this is a QH, and we want to get that h by itself, we need to divide both sides by the q. So divide both sides by q. So y'all look at this. On the right side, the q's cancel. All that's left is the h. So let me ask you this. Can I do anything to this side? And y'all say no. Good job. There's nothing I can do to that. So this equals F over Q. Okay, y'all? So I do these letters just like I would do numbers. Treat all these other variables like numbers, except for the one you're solving for, okay? How about this one? Solve for X. I've got B equals K times X. Now, y'all, here's one thing MathLab is picky about. If they use little letters like this, you got to write it as little letters in the answer. If they use capital letters like this one, you got to write the answer using capital letters. It's really picky about capital letters and lowercase letters, okay? So y'all, this one's just like the one I just did. How can I get this X by itself?
Divide K.
Divide K. Good job. Because y'all look on the right side, the K's cancel. K divided by K gives me a 1X over there. And guess what? You can't do nothing with the B over K again. So X will equal B divided by K. And if you notice, the one thing about formulas that's different from the 1.1, you're not really getting rid of anything. You're just rearranging it. So we're on the numbers. I could multiply numbers, add numbers, and end up with single numbers, okay? But when you got formulas, it's a little different, okay? But we're doing the same steps. How about one like this? Solve for the h again. I'm going to have t equals 2 h's plus 2w. So we're solving for the h. So y'all, the first thing we want to do is get the 2h over here by itself. So what can I do with the 2w?
Subtract it from both sides.
Subtract it from both sides. So I'm going to subtract 2w here, subtract 2w on that side. So look what happens. I get a t minus 2w. These 2w's cancel, leaving me my 2h. So formulas are tricky in that you can't really shrink them down. You're just moving this stuff from one side to the other. All right, y'all, my last step, divide both sides by 2. So you would come in and do t minus 2w divided by 2 equals to 2h divided by 2. Now on this side, these 2's will cancel, leaving my h. But y'all, here's the thing. Over here, we cannot cancel these 2's out unless the t had a 2 in front of it. Remember, this 2 applies to both of these. And we can't just cancel it out with one side. I would have to have a 2t minus 2w divided by 2 in order to cancel that. So y'all, this side does not simplify. So it's going to stay a t minus 2w over 2. Okay, so you got to watch out for, because some of the biggest mistakes, people want to come in and just cancel them 2's out, but we cannot do that, okay? Because remember, division and multiplication have to distribute over everything. So that is a little tricky. And then let's try this last one. They want us to solve for k. All right, they're giving me d equals 1/2 times kw. So y'all, here's what I would do to this. First thing I would try to do is get rid of this fraction. So since the fraction has a 2 in the denominator, I'm going to multiply both sides by 2. So I'm going to do 2 times d will equal 2 times my 1/2 kw. So y'all, 2 times d is 2d on the left side. Over here, look at that. The 2's cancel. And I got 1 times kw, which is basically just going to be the kw. And if y'all notice something about this, just like this b equals kx, if something's on top on one side and you move it, it moves to the bottom. This 2 was on the bottom on the right side, it moved to the top on the other side. Okay, y'all, solve for the k. I got one more step. What are you doing?
You will divide 2 by both sides.
Okay, there you go. So take the 2d divided by w, the kw divided by w. To the right side, the w's cancel, leaving my k. And y'all, once again, cannot do anything with that. So I get a 2d over the w. So just remember, the formulas, they follow the same rules as the numbers. We're just not able to get rid of them. We're just rearranging them, okay? All right, y'all. So any questions on those? So your 1.1 homework will have more problems because it's going through all those properties. And I think it had like 24, 25 questions. This 1.2 with the formulas, it only had like 4 questions. So 1.1 will be a little longer than this 1.2. All right, y'all. So let me go back to my questions on that. All right, so we'll stop that share. So y'all, that's tonight's lesson 1.1 and 1.2. So to stay on pace with me through the course, by Thursday night, you want to have this done. That way we can get right in on the next section that we're doing. So Thursday, we'll do 2 more sections. And this class does about a week or 2 worth of work, and it has a test. So there's like 5 or 6 tests in this course, okay? So what we learned Thursday night will be all the material for the first test. We'll review next week, and then I'll open that test up for the next week, okay? But for tonight, play with your 1-1 and 1-2. All right, so someone was asking, did any of y'all get disconnected? Okay, so Alicia must have just been on your end. All right, so any questions? So I'm gonna quit recording